Hello and welcome to lessons 7.1 and 7.2 on exponential notation. Our swabab for today is students will be able to learn exponential notation and exponential notation for powers of 10. The materials you will need include your math journal, pencil, whiteboard, marker, and a calculator. You actually do need a calculator for this lesson. All right, first up, turn to journal page 209. I'm going to try to make this video quicker. I just spent a half hour taping it and it deleted. I'm not happy. Anyway, math message. I want you to try to solve this one by yourself. The question asks, which is true? 4 to the third power equals 12 or 4 to the third power equals 64? Explain your answer. Please pause the video and check in with me. Okay, so which is true? 4 to the third power equals 12 or 64? I got 64 because 4 to the third power means 4 times 4 times 4. And of course, 4 times 4 is 16, and then 16 times 4 is 64. I also added in there, it can't be 12 because 4 to the third power doesn't mean 4 times 3. Moving on to the next part, exponential notation. In exponential notation, the exponent tells how many times the base is used as a factor. For example, 4 to the third power equals 4 times 4 times 4, which is 64. The base is 4 and the exponent is 3. The product, 64, is written in standard notation. Complete the table. I'm going to go over the first one with you, and then I'm going to ask you to pause it and complete the rest by yourself, because this is really easy. All right, so first row, it says 5 to the fourth power. Our base is 5. Our exponent is 4. As repeated factors, it's written 5 times 5 times 5 times 5, which equals 625. Okay, next one. We have 6 times 6 times 6 times 6. So that means it's 6 4 times. So in exponential notation, it's written as 6 to the fourth power. Our base would be 6, and our exponent would be 4. Now, to figure out the standard notation, of course, we have to multiply 6 times 6 times 6 times 6. Yikes, that's probably going to be our hardest problem yet today. I know 6 times 6 is 36, and since I'm multiplying 36 by itself, really, I'm going to do 36 times 36. Please pause the video and check in with me to make sure you get the same. So, in standard notation, 6 to the fourth power simply equals 1,296. Now, pause the video and complete the remaining of the 3 rows in this chart. Okay, you can see as repeated factors, 9 times is written 9 times 9. So in exponential notation, that's written 9 to the second power, or 9 squared. Our base is 9 and our exponent is 2, which equals in standard notation 81. The next one is actually quite easy. So there's a bunch of ones you're multiplying by themselves, which equals, drumroll please, just 1. So that written in standard notation is 1. In exponential notation, the base is 1 and the exponent is 7 because 1 is written 7 different times, so it's 1 to the 7th power. Last one. This is probably the hardest one. In order to get this one, I actually started with the repeated factors, and I started writing 2 times 2, and then I kept multiplying 2 by the number that I would get until I got 32. And so what I mean by that is I wrote down 2 times 2, which I know is 4, and then I wrote another times 2. So 4 times 2 is 8. Then I wrote another times 2, and so 8 times 2 is 16. And then lastly, I wrote another times 2, and 16 times 2 is 32. So then I sat and I counted up the number of 2's I had, and that was 5. So the exponent is 5, and whoops, I forgot to write the exponential notation. It's 2 to the 5th power. Okay, now, question 3, exponents on a calculator, you actually need your calculator for. So I'm going to show you with the calculator after I read the directions, and I'll give you a chance to do it yourself. So it says, use your calculator to find the standard notation for the bases and exponents shown in the table. Record your keystrokes in the 3rd column, and then record the calculator display in the 4th column. So I'm going to pause the video so I can show you an example of a calculator so you know what to type in. Our first question is 4 to the third power. When you type in 4 to the third power on your calculator, you're going to start by striking the 4. You're going to strike this arrow key, and then 3, and then hit the equals sign. So it would look like this. Okay? So the keystrokes you'd write as 4, arrow, 3, and then I suppose you should put in the equal sign because that's how you actually get the answer. And of course, your answer would be 64. So the calculator should have displayed 64. Now, I'm going to have you guys pause the video, and I want you to write in all of your keystrokes. I'll show you first. So again, 2 to the 4th power equals, okay? Finish writing in your keystrokes now, then press play. Alrighty, so your keystrokes should look like I have filled in below. Now, all you need to do is do that and type it into the calculator. But before you do, use your brains. Think about it. The last question says 1 to the 10th power. That means you're multiplying 1 by itself 10 different times. Please tell me you know what that equals. Write in the 1. You guys can do it on your calculator because I know it's fun, but you should know that equals 1. Same with the question just above it. It says 3 to the 2nd power. 3 times 3, right? Which is 9. Again, type it in the calculator for practice, but please don't lose your brains when you're using your calculator. And then, of course, figure out what 2 to the 4th power is. Press play when you're done. Okay, so you should have the answers that I have below. 2 to the 4th power is 16. Now we need to turn to a new journal page. The last page we're going to do together here is page 212, and the title of it is Guides for Powers of 10. You're going to have 2 study links today. One is basically the same thing you just did on the last page, and the other one looks just like this page. They're very easy. I do want to explain this to you, though, before I give you the study link. So, it says study the place value chart below. So you can see we've got a column for billions, and then we've got all the millions in there, all the thousands, all the ones. I'm going to kind of translate what this is telling you. Whenever you have the number 10 and it has an exponent next to it, like for example, let's say 10 to the 2nd power. 10 to the 2nd power simply means, or the 2 simply indicates how many zeros you put after the 1. So 10 to the 2nd power is 100. Not too hard, right? Whereas 10 to the 3rd power has, you guessed it, 3 zeros after it. So that number would simply be 1,000. Think of it. 10 to the 4th power would have how many zeros? I hope you said 4. So 10 to the 4th power would have 4 zeros, which is 10,000. I think you get the picture. I'm going to read the directions through for you, and then we'll complete the page together. This won't take us long. In our place value system, the powers of 10 are grouped into sets of 3. Ones, thousands, millions, billions, and so on. These groupings, or periods, are helpful for working with large numbers. When we write large numbers in standard notation, we separate these groups of 3 with commas. There are prefixes for the periods and for other important powers of 10. You know some of these prefixes from your work with the metric system. For example, the prefix kilo in kilometer identifies a kilometer as 1,000 miles. Use the place value chart for large numbers and the prefixes chart to complete the following statements. Alright, so their example, 1 kilogram equals 10 to the 3rd or 1,000 grams. Okay, question 1. The distance from Chicago to New Orleans is about 10 to the 3rd or 1 blank miles. Well, 10 to the 3rd power, if you check your prefixes chart, means 1,000 miles. So, write in 1,000, please. Spell it right. The word is on the page a couple of times, so spell it correctly. Question 2. A millionaire has at least 10 to the blank dollars. Well, I would sit and I would write out the number million. Do that right now on your whiteboard. So I have written 1 million next to question 2. 1 million. Now, count up the number of zeros. How many zeros does 1 million have? Oh, look, it has 6 zeros, so it means 10 to the $6. You also could have checked it up in the prefixes up here where it says million is 10 to the 6th power. Okay. Question 3. A computer with 1 gigabyte of RAM memory can hold approximately 10 to the blank or 1 blank bytes of information. Well, I'm going to be perfectly honest with you. I do not know what a gigabyte is, so I'm going to go up to my prefixes chart up here. And I notice that giga is 10 to the 9th power. So I'm going to put 10 to the 9th power, and 10 to the 9th power, of course, means 1 billion. So write in billion, spelling it correctly. Question 6. A computer with 1 terabyte hard drive can store approximately 10 to the blank or 1 blank bytes of information. So let's check what a tera means in our prefix chart. It says tera means a trillion or 10 to the 12th power. So fill it in. Hopefully by now you're getting the hang of this. This is just what your study link looks like. Question 5. According to some scientists, the hearts of most mammals will beat about 10 to the 9th or 1 blank times in a lifetime. So again, go up to your prefixes chart. Oh, I already have an arrow next to it. 10 to the 9th means 1 billion. So go ahead and write in 1 billion. Okay. Study link time. Here is what study link 7.1 looks like. Okay, so it says, or it reminds us that in exponential notation, the exponent tells how many times the base is used as a factor. So you need to complete the table, showing me what it looks like in exponential notation, what the base is, what the exponent is, repeated factors, and standard notation. I already have an arrow next to the last one there. You can do that one as bonus if you want, or you could just not do it at all. I think that is an absurd question to ask, so I don't care if you guys do that. All right, so question 1 is simple. Now, questions 2 through 4 is a little different, but I think you understand it. You just need to think about it. So it says, describe the mistake, then find the correct solution. So look at number 2. 6 to the 3rd power equals 6 plus 3, which equals 9. Well, hopefully you guys know by now that 6 to the 3rd power does not mean 6 plus 3. So first, note that as a mistake. 6 to the 3rd power does not equal 6 plus 3. So then for the correct solution, I would like you to put 6 to the 3rd power equals 6 times 6 times 6. And then if you would like to use your calculator for questions 2 through 4 to find the standard notation, I have no problems with that. In fact, I forgot to mention that with question 1, to find the standard notation for question 1, I have no problems with you using your calculator up there. Use the technique that I showed you with the arrow key. But the bottom of the page, the practice section, do not use your calculator. Use your brains, show your work. All right? Moving on to Study Link 7.2. Study Link 7.2, just like I mentioned, looks just like the page we just completed together. Use the chart at the top to fill in the blanks. Make sure to read carefully, and please make sure to spell the words right since it's given to you on the page there. There's no need for you to use a calculator on this page at all. It's just simply not worth it. So, where it says questions 7 and 8 at the bottom, prime factorization, I want to remind you, is writing it out as a factor tree. Remember, 48 equals what times what, and then keep breaking it down until you only have prime numbers. And then questions 9 and 10, you need to write those in expanded notation. And just a reminder, expanded notation, like if I had the number 126, expanded notation would be 100 plus 20 plus 6. I am not going to write that out. It takes me too long. So anyway, good luck with the study links, and until next time.